This is R.D. Sharma Solution, Class 12, Chapter 18. Maxima and Minima we are taking exercise is 18.4. Now this is a very easy exercise, and if you have done from 1 to 3, this 0.4 is very easy. Like Rahul Gandhi says, let us do it khatakat, khatakat, khatakat. So this is a new thing here. -2, 4 and it's 4.5 actually, the last one. Now when we make a curve, we have certain, crest and trough. That means the maximums and minimums, the local maxima, the minima. So if you are given certain points, like these are the critical points, so these are the points on which you have to find out the maxima or minima. So specific point are being already given. Previously, we have to find the critical point, then we can find out whether it is minima or maxima. Here already the critical points are given. So first thing what we do here is the differentiation. When we differentiate, this becomes 4 minus 2x divided by 2. So it's 4 minus x. And in order to find out the maxima and minima, we just put f dash x is equal to 0. So when you place it 0, 4 minus x is equal to 0. That means x is equal to 4. Now x is equal to 4. This is the critical point. And it still lies in the critical point list which is given in this question. -2, 4 or 4 then we have 5 or 4.5. So if you know how to solve -2 and 4, you can solve 5 and 4.5 as well. Okay, we are going in the right direction because x equals to 4 is the critical point. That also lies in the question being formed by the whosoever has made this question. So -2, 4 and 4.5 are these three critical points. One of them we have just found, and we have connected that the clarity here. That okay, we are on the right track. The next thing what we do here is we have to take all these critical points, and since already the critical point is there with us, we just have to find out the minimum and maximum value. So we will place these three values which are given in the question in the original equation, which is 4x minus x square by 2. So f minus 2 we have to do, f4 we have to do, and f4.5 we have to do. So I'm just placing the -2 value in the original equation, which is 4x minus x square by 2. Here also f4, it's 4 into 4 minus 4 square by 2. And as I said, the third number can be 4.5, it can be 5, because in different edition of R.D. Sharma, the numbers are different. But the logic remains the same, it will never change. This is -10, f4 is 8, f4.5 is 7.875. Now, what is the absolute minima and absolute maxima, or absolute minimum or absolute maximum? See, there are certain local minima maxima. So I made a graph. Now here one maximum will be the maximum of all. That is called the maximum. One minimum will be minimum of all. That is the minimum. But if you take any maximum which is maximum than the other around, this is called local maxima or local minima. It's not the highest one, but it is higher than the other one. That is called the local maxima and local minima. But when it comes to certain points, specific 2 or 3 or n points, then we say that whichever is the maximum in these given points is the absolute maximum or absolute minimum. I hope you have the idea now about the different kind of maximums we are talking about. Now you have to see the ascending order here. That is, the lowest one is -10. Then we have the 7.875 and the highest one is 8. So this -10 comes at f minus 2. So x equals to -2 will give you something. Here x equals to 4 is giving you 8, which is the maximum. Highest value is 8 at x equals to 4. So f4 is equal to 8. Similarly, this is the highest value I am talking about. Coming to the lowest value, which is the lowest among all these three. The lowest among all these three is -10. And -10 has come from when we place the value as -2. So at x equals to -2, we get absolute minima or absolute minimum, which is actually equal to -10. How are we going to write about it? So all these English language or these things you have to follow. X minus 2 whole square plus 3 in -3 and 1. Already the interval or the critical points are being provided. We just have to differentiate this function and we have to place it as 0 and see if we come up with some additional critical points. If it is not there, then we will check only on -3 and 1. Now f dash x we have already done, and we are placing it as 0. 2 into x minus 1 equals to 0. That means 2 cannot be 0. So x minus 1 has to be 0, x equals to 1. X equals to 1 already is in the list of critical points, which is -3 and 1. So we are following the right track, and the question is also saying giving us the right critical point, -3 and 1. The second thing will be, see, just check this function at -3 and 1. F -3, just put it here, -3 minus 1 whole square plus 3. 1 when we place, it will be 1 minus 1 whole square, that is 0, and plus 3 directly it will come as 3. When you compute this is 4 square is 16, 16 plus 3 is 19. So you got 3 and 19. 3 is lower than 19, or 19 is higher than 3. 19 we got at f minus 3, and 3 we got at f1, that is the critical point 1. So the lowest or the absolute minimum value is 3, which we received or we got when we placed x equals to 1. Similarly, the absolute maximum value we got as a 19, which is the maximum value, this one, 19. And this we got when we had x equals to -3. This is the reference for you. You can follow this reference and solve it. Next one is this one. This is the expression, and we have to find out the absolute maximum and minimum at the critical points 0 and 3. Now we have to check whether we have more absolute minimum or maximum points to be checked or not. That is the critical point. So what do we do here? We have to differentiate this. So first thing is the differentiation of this 3x raised 4 minus 8x cubed plus 12x square minus 48x plus 25. So this step I am differentiating it, and differentiation is quite known to you, quite well versed you are with differentiation. I hope that we have this differentiation. Now just place it as 0. You can take a 12 common because we can see 12 is everywhere in these terms, and just take divide both terms by 12. We only get x cubed minus 2x square plus 2x minus 4. We can take x common from here, x square common from here, x minus 2 will be there. And here we can take 2 common, x minus 2 will be there. Now taking x minus 2 common from all these, x square plus 2 will remain inside. X minus 2 equals to 0, that means x is equal to 2. X square plus 2 is equal to 0, that means x square equals to -2. This second term or second factor is not going to give you any critical point, because x square plus 2 can never be equal to 0. It can only be 0 when there are no real roots. There can be conjugate or say real and imaginary complex kind of roots, but we are not going to deal with this right now. X square cannot be equal to -2 in this case. We are only left with x equals to 2 here. So we have 0 and 3 already there in the question being given. But from here we got 2. There are 3 points here, 0, 2 and 3. And all these 3 points we are going to check for the actual value. So this 0, 2, 3 has to be placed in 3x raised 4 minus 8x cubed plus 12x square minus 48x plus 25. So I am now placing this value and trying to find out the different values we get after placing these critical points here, 0, 2 and 3. So once you place this f0, 0 is 25, f2, this f2 is -39, and f3 we are coming up with another number. And in these 3 numbers we have to see the highest one and the lowest one. So when we have f3, we got 16. So if you go with the ascending order, it's -39, and then we have 16 and 25. So let us write it like this. We have -39 here, -39. This comes at f2. It is lower than 16. That comes when it is f3. Then we have f0, this is 25. This is when we had f0. So minimum is -39 at f2. So at 2, x equals to 2, we got the -39. So this is the absolute minimum value, and f0 gives you absolute maximum value. This is the reference which you can follow in order to solve this question. And for those who want to do it by themselves, very essential. Now we have x minus 2 into under root x minus 1 in 1 and 9. So 1 and 9 are the critical points. And we would like to check, are there any other points that is the critical points which we need to check for the absolute maximum or minimum. First thing we'll do is the differentiation. That's what I'm doing right now. And since this can be done using the product rule, we can apply the product rule here. So x minus 2 differentiation is 1 only, so under root x minus 1. X minus 2 will remain like that. Differentiation of under root x minus 1 will be 1 by twice of under root x minus 1. And this you already know because differentiation is now very clear to you. Local, in order to find out the maximum minima, the thing is we have to equate it to 0. So I'm doing it here only. I'm equating in between, and on the right hand side the negative sign will come. So this already 3 steps I have done in one step. Let us cross multiply 2 into x minus 1. It will be on the right, it will be negative x minus 2. Let us write it as 2 minus x because negative is already there outside. 2x minus 2 is 2 minus x here. This goes here. 2x plus x is 3x and 2 plus 2 is 4. We get x is equal to 4 by 3. Now this is a new number which is in between 1 and 9. We cannot take any value which is outside the limit, which is outside this 1 and 9. 1 and 9, you can assume that these are the minimum and maximum for the critical point. So you have to take in between. We came to know that 4 by 3 is also one of the points which we need to check. So all the critical points includes 1, 4 by 3 and 9. The second step is going to be like this. We have f1 and f4 by 3. That is in the original equation. You have to place 1, 4 by 3 and 9. These 3 values we have to check for. I mean, we have to find out the value of y, that is fx, for the critical points, which is in this case 1, 4 by 3 and 9. I'm just placing the values in the original equation that you are witnessing right now. And mainly what I am trying to do is trying to find out the values. Under root 1 minus 1. 1 minus 1 is 0. Under root 0 is 0 only. So it becomes 0. Then we have this as 2 by 3 under root 3. And this is see 7 here. Under root 8 here. So under root 8 will be 2 root 2. It will be 14 root 2. We have 3 numbers now. And we have to arrange them in the ascending order. So 14 under root 2. Now you can very well see that 14 root 2 is the highest and 0 is the lowest. How did I come to know? Because under root 2 is, see, under root 2 value is 1.414, that you already are aware. Similarly, under root 3 is 1.732. So if you have say the possibility of having a calculator, you can calculate. But by the observation also, it's quite clear that we have the lowest number as 0 and the highest number as 14 root 2. So first number, the highest number is 14 root 2, which came with f9, or putting 9 we got this number. Then we have this, oh, this is negative 4 minus 6 by 3 minus 2 by 3. Oh, there is certain change which I am doing here, because this is going to be the first number. I was thinking that 0 is going to be the first number, but since we have negative also, we don't have to worry about what is there. Don't compute it, 2 by 3 under root 3. Just see that negative 2 by 3 root 3 is what we were expecting, and it's the lowest one. It came at for f4 by 3. So f4 by 3 provided us the lowest number, and f9 gave us 14 root 2 in this particular case. So this is the whole scenario. Now this is the way you have to solve, because writing is also important. One value which came was 4 by 3, which we used with 1 and 9. 3 values we used. And then we got the numbers, and then we found the absolute minimum, absolute maximum. Find the maximum value of this expression in the interval 1, 3. Find the maximum value of the same function in the interval negative 3 and negative 1. So these negative, there are different intervals, and before going ahead with the 2 different things which are being provided, we will do f dash x. F dash x equals to 0. But f dash x is what? Differentiation. So it is 6x square minus 24. So f dash x equals to 0. You are going to place this as 0. 6x square minus 24 equals to 0. We have 6x square equals to 24. 6 4s are 24. X square is equal to 4. And x will be equal to plus minus under root 2. That will give you under root 4. So it will give you x as plus 2 and x as negative 2. So we got 2 values, 2 and negative 2. So we have to use both of them or one of them. In this interval 1 and 3, can we have negative 2? No, we'll have 2 here. So in this critical point list 1 and 3, we'll include 2. But when we go to the second part of the question, it is -3 and -1. We already have -2 here. So we will use -1, -2 and -3. So I'm including 2 here with 1 and 3. And I'm including this -2 with -3 and -1. So these three values have to be placed in the original equation, that is F1 we have to find out. Original equation. So I'll just put this 1 as the value and try to find out the final value. Here F2, F3 also to be computed, F -3, F -2, F and -1, this also has to be used also. And all these values are going to come as numbers. And the basic criteria of us finding out the absolute maximum and minimum is the minimum and maximum value here. So I'm just writing all the numbers. 85, 75 will get here. F3 will give you 89. That is, the lowest number is 75, then followed by 85, and highest number is 89. 89 we got at F3. 75 we received at F2. So F2 is the critical point at which we got 75. 3 is the critical point at which we got 89, which is the absolute maximum. 75 is the absolute minimum. Same here we are going to do. F -3 I'm placing in the equation. Then we have the 139, 129 is 125, followed by this we got at -3, and this is 129, this is 139. So 139 is the highest one, which we when we got this at -2. -2 gave us the absolute maximum, -3 gave us the absolute minimum. So this is minimum and maximum. You don't have to find out the minimum value here. Only the question is asking about maximum value. So 89 and 139 is enough, right? Only mentioning 89 and 139 is enough for this question, rather than going for the others also, because only maximum value has been asked. Find the absolute maximum and minimum value of the function of given function f(x) equals to cos square plus sin x, x belongs to 0 to pi. So the first step is going to be f dash x, and between 0 to pi you have to find out. Okay, f dash x, this is going to be 2 cos minus 2 cos x, sin x will be cos x. And I'm going to place it here only 0, because this is ultimately we are going to do. And we'll just check for 0 to pi. Just keep an eye on it. I'm differentiating it. I've already differentiated it, so I'm taking cos x as common. Inside we have -2 sin x plus 1. Let us place them both as 0. Cos x will be 0 or sin x will be negative. This minus goes here, equal to half. So cos 0 is 1, cos pi by 2 is 0. Similarly, sin 0 is 0 and sin pi by 2 is 1. Cos x is 0 at pi by 2. Sin 30 degree is half. So we got two angles here. One was pi by 2, which is 90 degree, and pi by 6, which is 30 degree. Now this fortunately 30 degree and 90 degree lies between 0 and pi. So we already had two values, 0 and pi. So I'm placing or inserting pi by 6 and pi by 2 also, in order to check these critical points for maximum and minimum absolute. F0 you have to find out f pi by 6, f pi by 2 and f pi. Now this is related to trigonometry. Let us do it properly. Cos square 0 plus sin 0. Please remember, I am placing this in the original equation, which is cos square x plus sin x. Again, I am placing all these values here in order to show you that in between all these four, one will be absolute minimum, one will be absolute maximum. Cos square cos 0 is 1, sin 0 is 0, it gives you 1. Cos square pi by 6, sin pi by 6. Cos pi by 6 is root 3 by 2. This is going to be square. Sin pi by 6 is half. Again square 1 by 4. Root 3 by 2, that is 3 by 4 plus 1 by 4. That is going to be 1 by 2. So this 3 to the 6. 6 plus 4 by 8. This gives you 10 by 8, which is 5 by 4. Now this, again, I told you cos pi by 2 is 0. Sin pi by 2 is 1. When we square, we get 1. Again, this is sin pi, and cos square pi, again 1, because sin n pi is 0. Now you see, we got 3 1s and 1 5 by 4. Pi by 4 is greater than all these 1s. So at x equals to pi by 6, we got the highest number, which is the absolute maximum. But at 0, pi by 2 and pi, we got the minimum number, which is 1. 0, pi by 2 and pi. Now this is how we have to complete this, and all this writing is a must, which I told you, and you can try by yourself also. Now 12x to the power 4 by 3 minus 6x to the power 1 by 3, x belonging to negative 1, 1. We have to find out the absolute maximum and minimum values of a function f given by this. I am doing the differentiation straight away. So this 12 into 4 by 3, 3 4 is 12, 4 4 is 16. 16x 4 by 3 minus 1 is 1 by 3. Minus 6 into 1 by 3 is 2. 2x to the power 1 by 3 minus 1 is 1 minus 3 by 3, which is x to the power minus 2 by 3 it will come. Now just equate it to 0. When you equate it to 0, you are going to get x here. So this is 16x raised 1 by 3 is equal to 2. X raised minus 2 by 3. And 16 and 2 will give you 8. X 1 by 3 and x minus 2 by 3 will also give you something. This, wherever it comes, you can do it by yourself. I mean, I'm just giving you hints. This is just computation. Basically, logic telling and logic making you understand the logic is important rather than making you mugging up the question. Okay. So x is 1 by 8 here. Now this 1 by 8 is in between negative 1 and 1. So we have three critical points in this case. Minus 1 and 1 by 8 and 1. So we'll find out what f minus 1. We'll find out f 1 by 8 and f1. So when we place all these, what are we going to get? And you already know f negative 1, 1 by 8 and 1 I am placing and finding out the final value, which is going to be 18 in this case. 1 by 8 will be negative 9 by 4. f1 will give you 6. So highest and lowest you can just place it. This negative 9 by 4 and then we have 6 and 18. This 9 by 4 you got at f1 by 8 and this 18 was from f negative 1. Negative 1 gave us the absolute maximum. 1 by 8 gave us the absolute minimum. This is the final result. This is you are going to follow. Next one is find the absolute minimum and maximum of fx equals to 2x cube minus 15x square plus 36 plus 1, 1 to 5. And this is 1, 5 is the interval. So maybe we may get certain numbers which can be the critical numbers. 2 is already with us. I am doing the differentiation here. 2x cube is 6x square minus this is 30x plus 36 equals to 0. You can take 6 common or you can divide it by 6. So 6x square minus 5x plus 6 equals to 0. X square minus 2x minus 3x plus 6 equals to 0. This is simple factorization and I hope you will be able to do it by yourself. This is simply x minus 2 into x minus 3. Two factors we got is equal to 0. So either x minus 2 is equal to 0 or x minus 3 is equal to 0. That means x equals to 2 and x equals to 3. These are the two values which we can place in between 1 and 5. f1, f2, f3, f5 we have to find out the value, final value. And when we place all these values in this original equation, because 1, 2, 3, 5 all needs to be checked. f1 will come as 24, f2 will be 29, f3 will give you 28 and f5 will give you 56. So f5 is the absolute maximum and f1 is the absolute minimum. You can check it by arranging them in the ascending order or descending order and you can see the first and last number. That first and last number is only the interested part in this question, which is the absolute minimum and absolute maximum. So this is the whole scenario of this question and this is what I have spoken up and which is in front of you. So these all writing is important because if you don't write, how would the examiner know that these all you have done in these 3 parts or 4 parts? In question has always certain parts. Initial, then the center body and then the final. That is the conclusion. All these 3 parts have to be okay and I hope you have got the idea. Thank you so much. This is the end of this exercise.